Okay, we're going to take a look at question 4 in your AP packet of 10 questions. And I'm not going to do the whole question. I'm just going to focus on part C and D. There was a student request to sort of look at the difference between those two and why you do what you do. And I love the fact that somebody asked about this. And this is a core concept from this chapter. We started talking about this average value theorem, but we also have a way of finding average from first semester calculus. So this is definitely something you need to sort out in your mind. If you haven't already done the question, you want to pause this video and do parts A and B. At least read through the question, make sure you have an idea of what's going on. Okay, picking up on part C and D, assuming you're there. This one's asking in part C, I just noticed it's asking for the average value of the traffic flow, and then in part D, it's asking for the average rate of change of the traffic flow. So I'm going to have you pause the video, and I am going to, and I would just write down anything that comes to your mind when you think of average. And like I said, there should be at least 2 things that you're thinking right now. Okay, we'll pick up in a minute. Okay, assuming you wrote some thoughts down, let's compare your thoughts to my thoughts. So here are my thoughts that I have. 2 different thoughts that I have right now. And one is what you see here with the integral. So 1 over, you might be recognizing this as 1 over b minus a. In this case, we're going from 10 to 15 for my time. Time is measured in minutes. So 1 over 15 minus 10 is actually where I'm getting this 5 from. And then times the integral from 10 to 15 of my rate function, my traffic flow. Okay, so that one we're getting 81.899 cars per minute. Okay, notice that the units there are matching. This cars per minute is matching the units of this f function. So I know I've showed you this before, but this one is, my f function is cars per minute, and then times my dt is minutes. And those are canceling out, and that's giving me cars. Sorry, I had to pause there because I was like, wait a second, I'm getting cars per minute. That's giving me number of cars. The integral itself is giving me the number of cars that have passed through the intersection. And that might give you a hint to what you maybe are doing in part A. Should have done in part A. And how am I getting cars per minute here? Well, that's because of this 15 minus 10, or this 5, has a unit of minutes. That's a time interval from 10 to 15. So I'm actually multiplying by 1 over minutes. So that gives me a final answer of cars per minute. I know that gets confusing, but it really does help you sort out like what's going on. Okay, so that would be average value theorem applied to the function f of t. So remember, your average value theorem gives you the average of whatever function is inside. And I'm hoping at this point that you're able to determine, is this what I'm doing for part C or part D? I'm not going to tell you yet which one that is. Maybe you figured it out. Let's talk through the other one, and then let's see if maybe we can figure out which is which. So if you look at number 2 that I have on the screen here, the average number 2, average slope is slope of a secant line, average rate of change, AROC. We've called it all these things, taking the value at, so y2 minus y1 is what I'm seeing here, over x2 minus x1. And I know you can do that in your calculator. And we're getting, notice we're getting units here of cars per minute squared. Why would that be happening? Well, my units in my numerator, units of this would be cars per minute. And then my denominator, the 15 minus 10 is time. So that's minute. And there's my cars per minute, or cars per minute squared that you're seeing here. So maybe at this point you're making the connection. I did sort of hint at the fact that the average value theorem gives you the average of whatever functions inside. So notice that for part C we're saying average value of the traffic flow. The other way to think of that is that if you're finding the average of the traffic flow, your answer should be an average rate of the traffic flow. and I don't even know if I'm saying that right, but the average traffic flow should have the same units as the traffic flow function, which is cars per minute. So the first one is in fact what you should have done for part C right here. I've got the AP rubric, so this is giving you how you're getting your points. That one's worth 3 points. And then part D, average rate of change of the traffic flow. So this, I even said it as average rate of change. A slope is a rate of change. So you're finding the rate of change of the traffic flow. And if you really think about this as you read it, that's not going to be the same units as cars per minute. It's not going to be the units of traffic flow because it's the rate of change of traffic flow. So you've got to take your traffic flow units, cars per minute, and then do it with respect to time, minutes. I'm not sure if that helps. I hope it does. It's a really, like I said, a really good concept to work on and sort of wrestle with and make sense of. Hopefully you at least came up with those two things. Maybe you did the wrong one for the wrong part. Maybe I could see you doing for part C what you did for part D and then probably got confused when you got to part D. Before we end this question, I do want to take a quick look at the last thing on the screen here is that they do, notice that they ask you to do units of measure. And usually that is a separate point. In this case, they're giving you 1 point for both of them, the units of measure. They don't do half points, so you had to get them both or you wouldn't get that point. But that is pretty typical that if they ask you for units, they will in some way build that into the rubric. So they didn't give you a whole point for each, but together, collectively, that was 1 point. Okay, hopefully that helps. Like I said, please work through A and B if you didn't do that. I'm going to let you try those on your own.